Welcome. In this video I'm going to show you how you can obtain Hedges G for a one sample scenario using Python and my stikpetP library. I have a separate video where I won't be using my library, so you can watch that one if you're interested. I'm using currently JupyterLab with Python version 3.12. And this video will focus on just how to obtain the measure, not so much if you should. It's actually a correction on Cohen's D for one samples. I have a separate video on that one. To show you how it can be obtained, I need some example data, so I'll import pandas and then load some data adjusted a little bit for example purposes from the General Social Survey from 2012. I don't need all of its data, I just need one numerical field, so I'm going to be using the age field. I'll remove any missing values. There was one category actually in there, 89 or older, so I'm going to replace that simply with 90 for this example. Replace that and then make sure everything is numeric. So I really have numbers only in there. I set the hypothesized mean to, let's say, 50, so let's also enter that one in. The function of interest is in the stikpetP library, so you need to install that, but you need to install it via my GitHub, otherwise it won't work. Once it's installed, you can import it just like any other library. The function ES, effect sizes, hedges G, and then OS for one sample. Takes as input the data. Either I think a list can also work if I'm not sure. The mu, the hypothesized mean, if you don't set it, it will use the mid-range, so the maximum plus minimum divided by 2. And then you can set an approximation. If you don't set any, it will try to use the exact version. You can do an Hedges approximation, a Durlock approximation, or a zoo approximation. So let's take it for a spin, and as you can see in this case, the sample size is a little bit too large, so it used the XU approximation instead, and the G value is 0.101 or minus 0.101. You could perhaps use some rules of thumb for Cohen's D for this, although some might actually argue that you first have to change that because it's a one sample version to a regular version. From the top of my head, it then multiplies it with the square root of 2 or something, so you can convert it first. That gives it a slightly different value. Let's see if that actually changes things. And no, it doesn't. It's still very small according to Sobolovsky. You can actually set different references as well that use different classification rules of thumb, or of course talk to some experts in the field what should be considered high or low. Alright, I hope this video was helpful and thank you for watching.